السلام عليكم ورحمة الله. النهاردة هنكمل الفيديوهات الخاصة بالبارشال fractions الكسور الجزئية Part 8. وقبل ما نبدأ لا تنسوا دعم قناتي بلايك the video and subscribe my channel. فإحنا النهاردة هناخد case 1 with case 2 and case 3. وطبعا case 1 2 and 3 دول إحنا اتكلمنا عنهم بالتفصيل في الأجزاء السابقة. فناخد an application integrate 10x plus 4 over x power 6 plus 8x power 3 dx. And to solve this integral, you should factorize the denominator. So we are going to take x power 3 as a common factor. And then we have a bracket x power 3 plus 8. This bracket is called sum of two cubes, and then we can factorize it as small bracket x plus 2 and long bracket x power 2 minus 2x plus 4. And we can't do a factorization anymore, so we have x power 3 times bracket. This is the factorization of the denominator. And we can see that x power 3 represent case 3 and bracket x plus 2 represents case 1 and bracket x power 2 minus 2x plus 4 represents case 2. And case 1, 2, and 3 we discussed them in details in parts 1, 2, and 3, and you should see them for more details. So we can split this integral into small simple integrals. The integration number 1 comes from case 1. We have a over x plus 2. And the integration number 2 comes from case 2, which is integration bx plus c over the denominator. And then we have integral number 3 comes from case 3, which is integration d over x plus e over x power 2 plus f over x power 3 dx. So by using partial fractions, we were able to write the original integral into a summation of 3 simple integrals, and we are going to solve them. So let's start by the first integral. We know that a is a constant, and all the constants we are going to solve it later on. So the constant will go outside the integral, and we have the numerator is the differentiation of the denominator. So the answer is a ln x plus 2. Let's go to the second integral, which comes from case 2. To solve it, we are going to split it into two integrals. The first integral, to solve it, you must make the numerator in the form of the differentiation of the denominator. So we are going to divide by 2 and multiply by 2. And then we are going to add 2 and subtract 2. Then we are going to split this integral into two integrals. Here we took 2x minus 2, and here we keep 2 as it is. Then bring down the above integral. So we have 3 integrals. Now we have constant over denominator, and here we have constant over denominator. We can combine these two integrals with each other like this. Now we have two integrals. We have b over 2 integration 2x minus 2 over denominator plus b plus c integrate 1 over denominator. We can see that the solution of the first integral is b over 2 ln the denominator. Why? because the numerator 2x minus 2 is the differentiation of the denominator x power 2 minus 2x plus 4. So the answer is b over 2 lim denominator. Now let's go to the second integral, how to solve it. In part 2, we discussed this integral in more details, and we said that we should put the denominator in the form of sum or difference between two squares. So first of all, we are going to make a perfect square for the denominator. And also we took in the previous videos how to make perfect square. And now we have bracket power 2 plus constant, and also this constant can be written as root 3 power 2. And now we are going to divide by root 3 and times root 3. And this form takes the form of arctan. So the answer will be arctan x minus 1 over root 3. Now let's go to the third integral, which comes from case 3. And this integral, we are going to split it into 3 integrals. So the first one will be integration d over x dx. The second one will be integration e over x power 2 dx. And the third one will be f over x power 3 dx. So let's start by the first integral. We have integration d over x dx. D is constant, so the answer will be d ln x. And here we have integration e over x power 2 dx. Also e is constant, so the answer will be negative e over x. And by similar, we have the third integral will be equal to negative f over 2x power 2. And now it's time for getting the constants. So this is the solution of the original integral, and we should get the value of the constants a, b, c, d, and f. How to get these constants? As we said in the previous videos, we are going to make a common denominator like this. And then we are going to compare every small denominator by the common denominator and then write the missing. So here we have the missing is x power 3 and the long bracket. So here we are going to write a times x power 3 times the bracket. By similar, we are going to compare the next denominator with the common denominator, and the missing is x power 3 and the small bracket. So the answer will be numerator bx plus c times the missing x power 3 times small bracket. By similar, we are going to compare the denominator x with the common denominator. So the missing is x power 2 small bracket and long bracket. By similar, we are going to compare the denominator x power 2 and the missing is x times small bracket times long bracket. And by similar, we are going to compare the denominator of f with the common denominator. So the answer will be the small bracket and the long bracket. And also we have the original integral equals to integration 10x plus 4 over the same common denominator. So the numerator must be the same. So we have the left hand side equals to 10x plus 4. And we are going to regroup the left hand side so that it will be like this. And left hand side is equal to 10x plus 4. And as we said before, if two polynomials are equal, then the coefficients must be equal. So here we have the right hand side can be written as 0 times x power 5 plus 0 times x plus 4 plus 0 times x power 3 plus 0 times x power 2 plus 10x plus 4. And then the coefficients are equal, so we have a plus b plus d equals to 0, and negative 2a plus 2b plus c plus e equals 0, and 4a plus 2c plus f equals 0, and 8d equals 0, and 8e equals 10, because 8e is the coefficient of x, and here we have 8f equals 4. And here from 8d equals 0, we have d equals 0. And also from here, we can see that e is equal to 5 over 4. And from here, we can see that f equals half. And we still have 3 unknowns in 3 equations, A, B, C. And you can solve them using Gauss elimination method or Cramer's rule. And if you don't know them, you should see our videos for Gauss elimination and Cramer's rule. So the answers will be A equals 1 over 6, B equal negative 1 over 6, C equals negative 7 over 12. And then we are going to replace the constants by their values. And then we get the complete solutions of the integrals. Return back to our problem, and then we have the solution will be like this. And don't forget to add the constant of the integration.